Okay, so today I'm going to share with you a little bit about my research on active bodies, focused minds, and how exercise boosts learning. So, the leading causes of death in Canada and the US are due to behaviors we can change, such as smoking, high fat diet, alcohol consumption, and physical inactivity. And my research focuses on how we can get people to move more and how physical activity impacts our health. And we see that there are socioeconomic, racial, and ethnic disparities in these health behaviors, and then the associated chronic diseases that go along with physical inactivity, leading to higher cardiovascular risk factors among many First Nations, South Asian, and Black populations, as well as there being income inequality in limiting conditions and income. But we see that engaging in physical activity over weeks and months can lead to improvements in cardiovascular health, as well as decreased risk in obesity. But this takes a longer period of time. So, what if I told you there was something that you could do immediately within about 10 to 20 minutes of being physically active that could boost your brain health? And what our work shows is that short bouts of physical activity improve attention almost immediately. And we know this because we've used what are called event-related potentials that let us measure people's brain activity. And so what we do is we have people come into the lab, we put on an EEG cap that has a bunch of sensors that lets us look at electrical activity in their brain. And they typically do this while they're seated at a computer and performing a variety of tasks. And what we get are a bunch of squiggly lines. And when we're able to average them, we're able to get uh, average waveform, and that can tell us about people's cognitive activities. And so the one that we particularly look at is called the P3. And so it's a waveform that kind of looks like this. And we see that the amplitude or size of that wave tells us about people's attention. And we can look at this by having people do what is called a flanker task. And so for a flanker task, people have to press a button based on the middle letter. And the middle letter will be having matched letters on the side or unmatched letters on the side. So here you see there is a B in the middle, and sometimes there's D's on the other side and B's. And so this task tells us how people are able to focus on that middle letter and ignore the distracting letters. And so people did this while they were seated. We had an EEG cap on them as well as an eye tracker that measured their size of their pupils. And they did this before and after 20 minutes of walking on a treadmill. And I'm going to share with you our EEG findings. So we had about 58 university students come into the lab, and half of them did exercise on the first day and then did active control on the second day. And this was separated by about a week. And the other half did the opposite order of these 2 days for the experimental conditions. And so we see that the physical activity got them into about that moderate intensity physical activity. So that's kind of like walking as if you're, late for class or an appointment. And our active control was walking on the treadmill at the slowest speed with 0% grade. And this was the equivalent, metabolic equivalent of seated when we measured that in the lab. And we did this to eliminate any potential confounding factors such as change in posture and other physiological things that could arise. And so what did we see? We see that we have this beautiful waveform with P3. In blue, we have the active control, and in green, we have a exercise post-test. And so what we see is that at post-test, attention was greater following physical activity relative to that active control. And then I'm going to put those pre-test there. So you can see from pre to post, we see that the exercise condition increased attention, while as attention was decreased following the active control. And we see this reflected in the head plots, where the active control relative to the exercise has a difference in the activation for the allocation of attention. And so this tells us that just a single dose of physical activity, 20 minutes of a brisk walk as if you're late for class, can actually enhance your attention almost immediately. And so my work has extended this outside the lab and is interested in going beyond the lab to look at how this can be applied in academic settings with schools and with younger populations, because we don't have a ton of information in children, especially younger children. And so schools, are where kids are 25 to 50 hours in childcare or school setting weekly. And this is where they're able to get most of their physical activity. So, building on my career as a teacher, I started to ask the question, how can we increase physical activity in schools, support school readiness, like self-regulation and learning? And so in Canada, we have most provinces and territories have a daily physical activity policy. And this says that 20 to 30 minutes daily during instructional time is required. But recent research has shown that only about 50% of teachers are able to implement this daily physical activity policy. This is coming from Western University, University of Western Ontario. Dr. Barb Benisi is the Canada Research Chair of the Science of Learning. And recent research with that research group showed that, yeah, there's about 50% of teachers that aren't able to meet this daily physical activity requirement. And so the barriers they say are there's not enough time, they have to prioritize academic instruction, and there's concerns with behavior management if they go and do something physically active and then getting kids to settle down after. And there's not enough space to do these things. So my research looked at the early childhood standards of quality in Michigan and looked at how we could integrate physical activity with early learning expectations, such as attentiveness, self-regulation, gross motor movement, comparing quantities, counting to 10, and the correspondence of counting to numerals. And so this was a lab-based study with the goal of extending to schools in the future. And we developed a quantity estimation task based off of prior work. And in this task, kids were seated at a computer and they were asked to press the button that has the side with more fish. And we had three different conditions, varied the difficulty of being able to tell the difference between these two quantities. And so this is an important early numeracy skill. And we decided to measure this as well as behavioral self-regulation. So we had a trained observer who, throughout the experiment, noted the number of times that a child was off task. And these were things such as getting up out of the seat, running around the room, talking to the experimenter, stopping the task, and throwing the buttons. There were lots of things that preschoolers, I'm sure you can imagine, get up to while they're asked to sit and do this fish game. And this was to be consistent with the types of things that teachers may redirect students for in the classroom and those types of behaviors. And so kids came into the lab on two separate days, separated by about a week. Half the group did the physically active instruction. Well, on the second day, they did the conventional sedentary instruction. And the order of these were reversed. We had about 51 children, 3 to 5 years old, come and do these 2 days. And so we had three different types of math games for the kids. We had a number line estimation. So kiddos had to estimate kind of like a board game where they would have cards and have to estimate that quantity on a numbered line from 0 to 10. And in the physically active instruction, they had to do that, but instead they were going to be moving around and jumping or doing some type of movement related to an animal, getting to that position on the number line. We also had kids do a less than or greater than game. And so they had to indicate whether the quantity they saw in this card game was less than 5 or greater than 5 on that number line. And in the physically active condition, they were going to throw and toss a beanbag into a hula hoop to indicate whether the quantity was less than 5 or greater than 5. And they'd have to go and retrieve the beanbag. So there was movement integrated with that. And the other one was counting, where they had little counting bears, where they would manipulate and count those quantities while they were playing with the experimenter, the card game. And in the physically active condition, they were running around the room, bouncing a ball, practicing some gross motor skills with bouncing and ball control, bouncing in a hula hoop. And so these games that were physically active were simply integrating physical activity to those same seated stations that teachers would often have in their classroom for kids to, preschoolers to learn basic counting and estimation skills in the early childhood classroom. And so what we saw was that we were able to get kids into that moderate to vigorous physical activity range, and they were able to get, over 900 steps. And the total session was about 20 minutes. And when we looked at our findings, we found that behavioral self-regulation actually improved following physical activity. So we have better self-regulation here on the lower part. And there was a significant difference at post-test when kids did the physically active instruction. They didn't have to be redirected as much. But after the sedentary instruction, they had to be redirected a lot more. We see overall that in the heart rate intensity, they got about 15 minutes at moderate intensity, and this accounted for about 10% of their daily recommended steps. If we assume 10,000 steps, which there isn't really a guidance for that with young kids, but so anyways, we got kids moving. And this is important because they didn't have to be redirected as much. So that classroom management concern was actually not what we observed. So we see that with just a short lesson aligning with daily physical activity policies and using activities that kids are already doing in a preschool classroom, we can improve self-regulation and behavior management. And this does not compromise academic instruction, doesn't require a ton of space. We could actually do this with existing equipment. And we can do these activities where we're still meeting early learning standards. So that helps address the concern about time, behavior management, and maybe why teachers aren't doing these daily physical activity requirements. So it doesn't have to be something above and beyond the curriculum. It can be something that teachers are already doing in the classroom, and we just need to get kids moving. And why is this important? Well, it's because overall, we know that active kids become active adults. So if we're able to get kids moving more in school, we're able to reach more kids, and we're able to help protect against obesity, heart disease over time. If we're able to do these active learning opportunities with the curriculum and getting kids active for life. And so I hope to continue this line of work and begin to partner with schools to be able to implement these types of interventions in a school setting and get more kids being active and seeing how we can integrate it across different curriculum outside of math. But we were able to do it with math. All right.